All right, today we're going to do the last lesson in Unit 3 over factoring linear expressions. So first thing we're going to do, we're going to kind of skip this top part. We're going to talk about what a factor is. And a factor is the numbers that you multiply to get to a specific number. So over here I have 16 written, so go ahead and write 16. And then we're going to write all of the factors of 16. So all of the numbers that when you multiply, they can get you to 16. So our first set of factors is 1 and 16, because 1 times 16 is 16. The second pair of factors that make 16 would be 2 and 8, because 2 times 8 is 16. 3 does not go into 16, so 3 is not a factor of 16. 4 goes into 16, so 4 times 4 is a factor of 16. 5 doesn't go into 16, 6 doesn't go into 16, 7 doesn't go in. I already have 8 written down. And then 9, 10, 11, 12, 13, 14, 15, none of them go in either. So these are the factors of 16, and if you were asked to write them, you would simply write the factors of 16 are 1, 2, 4, 8, and 16. Now, finding factors and finding a greatest common factor should be review. When you were in a lower grade, they probably taught you to find greatest common factors by making a factor list and then circling the biggest number that they had in common. At this point, I could probably say what is the biggest number that I could divide out of 8 and 12, and you would be able to tell me. If not, you can always make a factor list to help you figure out what numbers go into what you're looking for. So for 8 and 12, we're actually going to go ahead and make factor lists, and then we're going to find the biggest one that they have in common. So factors of 8. 1 and 8 are factors of 8, and 2 and 4 are factors of 8. 3 doesn't go in. I already have 4 written. 5, 6, and 7 don't go into 8. So these are my 4 factors for 8. So 1, 2, 4, and 8 are the factors. Factors of 12. 1 times 12. 2 times 6, so 2 and 6 are factors. 3 and 4 are also factors. Now, 5 doesn't go in, and then there's nothing else. So my factors for 12 are 1, 2, 3, 4, 6, and 12. So those are all of the numbers that I can divide into 12. Now, between the two lists, I see that they have multiple factors in common. They both have a 1, they both have a 2, and they both have a 4. When you are looking for the greatest common factor, you are looking for the biggest number that can be pulled out of both of them. So between 8 and 12, the largest factor that I can pull out is a 4. So that means the greatest common factor between 8 and 12 is 4. We can also do this when there are variables. You do it very much the same way. You say, what is the greatest factor that I can pull out of the number part? So between 4 and 18, the greatest factor that I can pull out of both of those is a 2. So I would say the greatest common factor, and then I would start with 2. Now, to pull a variable out and make it a greatest common factor, both of the terms have to have that variable. So looking at this one, 4x and 18xy, they both have an x, and because they both have an x, that could be pulled out as part of my greatest common factor. They both do not have a y, so the y cannot be pulled out and made my greatest common factor. So between 4x and 18xy, my greatest common factor is 2x. Moving down here, 16ab and 32b. I'm going to first look at the biggest number that I can pull out of 16 and 32. Now, this one is sort of tricky because a lot of people will want to pull 8, but there's actually a bigger factor that they have in common The biggest factor I can pull out of 16 and 32 is a 16, because 16 goes into 16 and 16 goes into 32 two times. So the greatest common factor number part is 16. Now I'm going to go through my letters. They don't both have an A, so I cannot pull an A. They both have a B, so then I can list the B. So the greatest common factor between 16AB and 32B is 16B. Last one, 27 and 45. We are looking for the greatest common factor between the two terms. A lot of people get stumped on this one. Think about numbers that go into 27, and if you need to, you can list them. 1 goes into 27, 3 goes into 27, 4 does not, 5 does not, 6 does not, 7 does not, 8 does not, 9 goes into 27, and then nothing else until 27 goes into 27. So those are the factors of 27. So it always helps to start making a list, if possible, for numbers that go in. Now looking at those numbers, I know that 1 does go into 45, 3 goes into 45, and 9 goes into 45. 27 does not. So the greatest common factor for the number part would be 9. Only one of them has an X, so I cannot pull an X into my greatest common factor. So the greatest common factor between 27 and 45X is 9. Okay, flip it over to the back of that page. Now, over here in this sort of like blank area right up here, you'll notice that I wrote this expression. I'd like you to go ahead and write that expression too. This is a very brief review of the distributive property. The distributive property was in lesson 2. So on your paper, write 3 times, and then in your parentheses, x plus 3. Okay, now to review the distributive property, remember we split the terms. We said there are 2 terms inside the parentheses. That means I make 2 boxes. Now, I had to put things around the boxes. So something went in front, above, and above. So the number in front of my parentheses was the number that went in front of my boxes. My first term went above my first box, so this is x. And remember, that's like a 1x if you still need to put the 1 there. And then my second term with the operation sign go above the second box. So I brought a plus 3 down. And then to get what goes inside the boxes with the distributive property, we multiplied to get what goes inside. So 3 times 1x leaves me with 3x. And 3 times a positive 3 left me with a positive 9. And my very last step was to rewrite the expression 3x plus 9. Factoring an expression is basically like taking the distributive property and going in reverse. So when we are factoring an expression, they will start you here and they will ask you to go backwards to get to the expression with the parentheses. So, looking at our first one, 5x plus 15. We're still going to split our terms. There are 2 terms, so I'm still going to do 2 boxes. That's not a box. There we go. Now, this time, instead of writing around the boxes, the expression that they give you when it doesn't have the parentheses, these go inside of our boxes. So our first term goes inside of our first box, and our second term with the operation sign goes inside the second box. Now your job is to figure out what's the greatest factor I can pull out of both of those terms, and then I divide to figure out what goes above the boxes. So we're working in reverse. Between a 5x and a positive 15, the biggest factor that I can pull out is a 5. So 5 goes on the top. 15 goes on the bottom. 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 15 goes on or excuse me, goes in the front of the boxes. Now, to get what goes on top of the boxes, I need to do division to get those terms. So 5x divided by 5 leaves me with 1x, or I could just write x. A positive 15 divided by 5 is a positive 3. Now my final step is to rewrite the expression with the parentheses. So I'm going to put a parentheses, and now I'm going to put the things that I have around my boxes into my expression. So 5 is in front of the boxes, 5 goes in front of my parentheses. 1x plus 3 is above my boxes, so 1x plus 3 goes inside of my parentheses, and this is my factored expression. Now, please remember that I also could have just done 5 times and then x plus 3. It's the same thing. Remember, the 1 is implied on that x, so even if I don't write it, it's the same thing. Let's practice some more. Moving down, 36x minus 48. The first thing I'm going to do is split and see that there are 2 terms. So 2 terms means 2 boxes. Maybe. Not a box, but let's see if I can get a box this time. There we go. Okay, so 2 terms, 2 boxes. And remember, we are taking the expression, the terms in the expression, and putting them inside the boxes this time. So 36x goes in the first box, and a negative 48 goes in the second box. And we are looking for what I can pull out to put in front and then above my 2 boxes. Now for this one, a lot of times people tell me that the biggest factor that they can get in is 6. So I'm going to put a 6 in the front. Go through the division. 36x divided by 6. 36 divided by 6 is 6, and then keep your variable. So 36x divided by 6 is 6x. And then a negative 48 divided by 6 is a negative 8. And if you struggle with multiplication and division doing it quickly, you most certainly could do that on your calculator. Now, here's where I want you to stop. Because looking up at this top section, and I'm going to circle what I'm talking about in green, you'll notice that I can still pull a number out of a 6 and an 8. That means that I did not get the greatest factor in the front, and so this is not correct. Looking at 6 and 8, you can look and see what you could still pull out of them. So between 6 and 8, I could still pull the factor 2 out of both of them. So that means if I take this 2 and I multiply it by this 6, that tells me what should go in front of the boxes. So I'm going to erase all my stuff in green. And now I'm going to erase these. Ooh. My eraser is too large. Okay. So I had a 6 and then in the front, and I could still pull out a 2. So I'm going to do 6 times 2, and 6 times 2 is 12. So that means 12 is the largest factor that I can pull out of a 36 and a 48. Now, going back through my division, 36x divided by 12 leaves me with 3x. And a negative 48 divided by a positive 12, again, if you're not great with this, do it on a calculator, is a negative 4. You'll notice now that between 3x and the negative 4, there are no more numbers that I could pull out of them. Those are as small as they can get. So that means that I do have the smallest factor in the front of my boxes now, so I'm doing it correct. If you can still pull factors out of this, you're not quite factored all of the way, and you have to factor your expression all the way. Our last step for this is to rewrite it with parentheses. So 12 goes in the front of the parentheses, and then inside the parentheses, I do 3x minus 4. Okay, let's do one more example together. 8x plus 17. First thing we're going to do is split them. 2 terms, 2 boxes. Okay, our first term goes inside the first box, 8x, and our second term goes inside the second box, plus 17. Now, I'm looking for the biggest factor I can pull out of an 8x and a 17. So thinking about numbers that go into 8, 1, 2, 4, and 8 are my factors. Well, I can definitely pull a 1 out of a 17. I can't pull a 2 out, I can't pull a 4 out, and I can't pull an 8 out. So I want you to write this over on the side. If the largest common factor, meaning it is the biggest factor for both of them, if the largest common factor is 1, the expression is prime. And what that means is if you can't pull anything bigger than a 1 out of them, you can't factor the expression. It's already factored all of the way. And when you can't factor a number, we say that it is a prime number. So when you cannot factor an expression because there's nothing that you can pull out from both of them that's bigger than a 1, you say the expression is prime. There are 4 problems underneath. Go ahead and try those 4 problems on your own. Pause the video, work through them. When you're done, unpause the video and check your answers with mine. All right, now that you've had a chance to go over it, we're going to go over it together. So looking at my first one, I split my terms. 7x goes in the first box and plus 21 goes in the second box. I am looking for the biggest factor I can pull out of 7x and 21. The biggest factor that I can pull out of both is a 7. So now I divide to get what goes above the boxes. 7x divided by 7 leaves me with 1x, or I can just write x. And a positive 21 divided by 7 leaves me with a positive 3. Now my final thing is to rewrite it with my parentheses. So I write 7 outside the parentheses, and then in the parentheses I write x plus 3. Now remember, if you're still putting a 1 in front of the x, meaning you have 7 times 1x plus 3, it's not wrong, but start getting used to seeing it without that 1 because the 1 is implied. Let's move on to our next one, 36x minus 54. 36x is my first term, goes in the first box. Negative 54 goes in my second box. I am looking for the biggest number that I can pull out of 54 and 36. Now, most people tell me that 9 is the biggest factor that they can pull out. 9 goes into 36x 4 times, so it would be 4x. And then a negative 54 divided by a positive 9 is a negative 6. If this is what you did, remember, stop and look. I can still pull something out of a 4 and a 6. I can still pull the factor of 2 out. So that means I did not get the biggest number in the front. So let's go back and fix that. If I can still pull a 2 out of a 4 and a 6, I'm going to take the factor I did pull out and multiply it by 2. 9 times 2 is 18. So that means the biggest factor I should have pulled to the front is actually 18. Going back through, 36 divided by 18 is 2. So 36x divided by 18 is 2x. And a negative 54 divided by 18 leaves me with a negative 3. Our last step is to rewrite the expression with the parentheses. 18 goes in the front. Inside my parentheses, I have 2x minus 3. And that's my answer. Moving down to 6x plus 13. First thing I'm going to do is split them and write them inside the boxes. 6x goes in the first box, and plus 13 goes in the second box. Now, numbers that go into 6 are 1, 2, 3, and 6. And none of those numbers besides 1 can go into 13. So when the biggest number or the biggest factor that they have in common is a 1, the expression is prime. Last but not least, 13x plus 39, I'm going to split my terms. 13x goes in the first one, and plus 39 goes in the second box. Now, a lot of times kids struggle with 1 because they look at that and they say, well, 13, the only numbers that go into 13 are 1 and 13. And that's true. So since those are the only numbers that go into 13, now you need to see if one of those two goes also into 39. 1 definitely goes into 39, but 13 also goes into 39. So since 13 goes into 39, the biggest factor you can pull out is a 13. 13x divided by 13 is 1x, or I can just write x. And a positive 39 divided by 13 is a positive 3. My last step is to rewrite the expression with my parentheses. So 13 goes in front of the parentheses, and x plus 3 goes inside, and that's my answer.